Okay. Yes, I have a piece of gum in my mouth. Hopefully it's not too distracting. I'm just gonna put it down. One page of my refrigeration book. This is one of 3 pages. Okay, first, force, work, and power. Force, work, and power are interrelated ways of measuring the application of energy. In the sections that follow, the connections between these measurements will be explained. Force. Force is energy applied to matter that, unless counteracted by opposing forces, causes a change in the matter's velocity. The unit force is the pound force, measured in pounds. The pound force is that force which, applied to a 1 pound mass, will result in an acceleration of 32.2 feet a second squared. This value of acceleration is known as the acceleration constant. On Earth, where the acceleration of gravity is 32.2 feet a second squared, an object with a mass of 1 pound exerts a 1 pound force on the surface on which it rests. In figure 1.2, this force is the weight of the object. If the object of a 1 pound mass were on the moon, where the gravity is about 1/6 of that on Earth, the weight of the mass would be 1/6 of a pound force. In SI units, standard imperial, the unit of force is the Newton. A Newton is that force which, applied to 1 kilogram mass, will accelerate the mass at a rate of 1 meter a second squared. Since the acceleration due to gravity is 9.8 meters a second squared at the surface of the Earth, and the Newton is based on acceleration of 1 meter a second squared, the mass in kilograms must be multiplied by a conversion factor of 9.8 when calculating gravitational force, weight, in standard imperial units. So the formula for gravitational force in SI is F in newtons equals mass in kilograms times acceleration due to gravity, which is meters a second squared. Unit equivalence. 1 pound of force equals 4.45 newtons. 1 newton equals 9.8 kilograms times meters a second squared equals 0.22 pounds of force. Work. Work is force, F, multiplied by the distance, D, through which it travels. The U.S. customary unit of work is called the foot-pound. 1 foot-pound is the amount of work done in lifting a 1 pound weight a vertical distance of 1 foot. Work is sometimes expressed in inch-pounds. At such times, the distance through which the force acts is measured in inches. Since the SI unit of work is called the joule, J. The joule is the amount of work done by a force of 1 newton through a distance of 1 meter. Work may also be measured simply in units of Newton meters. Newton N times M. Although this unit is usually reserved for measuring torque, which is rotating or twisting. The formula for calculating work is work equals force times distance. Unit equivalence, 1 foot-pound force equals 1.356 joules, which equals 1.356 Newton meters. 1 joule equals 1 Newton meter, which equals 0.737 foot-pounds. Okay, I feel like doing some electricity. Going to the front of the book to figure out where all the electrical is. Okay, I'm putting you down. I gotta figure this out. Okay, 272. Okay, honestly, I'm just going to read out the very front page of electrical control systems, like the learning objectives, technical terms, a view of key concepts, the introduction. So, learning objectives. Information in this chapter will enable you to understand the difference between pictorial and ladder circuit diagrams, summarize how control system use sensors, controllers, and actuators to maintain a conditioned area, explain each type of control system action and how it operates to achieve a desired condition, describe how range and differential adjustments are used to calibrate temperature and pressure controls, identify the various types of temperature sensing devices used in motor controls, compare the operation of various electromagnetic and electronic motor starting relays, test and evaluate various starting relays for proper operation, explain how motor protection devices protect motors from current overloads and overheating. Technical terms. Above atmospheric pressure element actuator. Above atmospheric pressure element. And then actuator. Anticipator. Below atmospheric pressure element. Bimetal coil. Bimetal device. Bimetal disc. Bimetal strip. Blown fuse. Circuit breaker. Closed loop control system. Conditioned area. Contactor. Control point. Control system. Controller. Current relay. Current limiting fuse, cut in, cut out, differential adjustment, fast acting fuse, feedback, floating control, fuse, impedance, ladder diagram, lockout relay, low side pressure limiter, modulating control, motor starter, multi-purpose fuse, offset, on/off control, open loop control system, pickup voltage, pictorial diagram, positive temperature coefficient relay, PTC, potential relay, pressure motor control, range adjustment, relay, remote temperature sensing element, sensing bulb, set point, solid state relay, SSR, system overshoot, timed on-off control, time delay fuse, tripped circuit breaker, volatile fluid, Wheatstone bridge. Review of key concept. Reviewing these concepts from earlier chapters will help you understand new concepts presented in this chapter. Series circuits provide current with a single path to follow, whereas parallel circuits allow current to flow along two or more electrical paths. That's in Chapter 9. Control systems use sensors to detect and respond to a stimulus, such as a change in temperature or pressure. Chapter 11. A relay is an electrical switch that opens or closes a circuit when its coil is energized by an electrical signal. Chapter 11. Signal phase AC motors use start and run windings and start capacitors or a combination of these to produce the torque needed to run. Chapter 12. Devices such as fuses, circuit breakers, and thermistors are used to protect circuits from current overloads and overheating. Chapter 10. Introduction. Electrical control systems are used to regulate the operation of an HVAC/R system and protect its components from operating outside of their design boundaries. From controlling a compressor's on-off cycles to modifying the position of a damper in a heating duct, electrical controls help HVAC/R systems automatically produce the desired condition in a space. In addition, control system components can be used as safety devices to detect unsafe operating conditions and shut down a system before any damage occurs. This chapter focuses on the fundamental operation of control systems and explains how the components used in those systems function. More detailed information about application-specific controls, such as defrost controls, is presented in the chapter dealing with those systems. Circuit diagrams. Electrical circuit diagrams come in a variety of forms and styles. Each type of diagram has a specific purpose. There are two main styles of diagrams that HVAC/R technicians will encounter: pictorial diagrams and ladder diagrams. A pictorial diagram or pictorial wiring diagram is primarily used in service or installation manuals to illustrate how to connect electrical devices in a unit. A technician can use a pictorial diagram to trace wire connections between devices. This is useful for locating a loose or omitted connection. Pictorial diagrams not only show all of the connections among a circuit's devices, but they also show the approximate physical location of devices in a unit. For example, if a pictorial diagram shows a junction box in the lower right corner, a technician can open up the main service panel and find the junction box in the lower right corner. By illustrating a device's physical location, a pictorial diagram helps technicians identify devices they may not be familiar with. In addition, pictorial diagrams give the colors of wires running to and from devices, which further aids a technician in verifying the devices in a circuit. Ladder diagrams, or line wiring diagrams, are two-dimensional representations of an HVAC-R electrical circuit. They are often provided by manufacturers with their units for troubleshooting electrical problems. HVAC-R units usually have a ladder diagram glued to the back of the unit or the unit's access door. A ladder diagram of a typical domestic refrigerator is shown in figure 13.12 or 13.2. A ladder diagram, the vertical lines in a ladder diagram, the vertical lines identify the power supply, and the horizontal lines contain the various controls and loads located in the circuit. Most electrical control systems are a combination of series and parallel circuits that switch electrical loads on and off. Ladder diagrams use a set of symbols to show the devices and connections arranged in the order that they activate during circuit operation. Okay, might as well show you that. That is a pictorial diagram. Okay, this has been fun. I will see you soon.